Okay, we're learning implicit differentiation. I want to do another quick example, and then I'm going to go over to Desmos and show you what this looks like. So the equation is x squared plus 4y squared equals 9. We're going to find dy over dx, and then actually we're also going to talk about what the tangent line equation would look like once you figure that out. So you may recall from pre-calculus or college algebra 2 that this equation produces the graph of an ellipse. So I've drawn roughly what the ellipse looks like. It's sort of a horizontal ellipse like this. And I want to remind everybody that the situation we're in here is we're talking about finding a rate of change in y with respect to x, which means if you have a point whose coordinates are, the point is on this ellipse, then when we use implicit differentiation to find this, you would be able to take the coordinates of that point, stick them into the formula, and figure out the slope of the tangent line at that point. And with that, coordinates and slope, we'll be able to get an equation. So, just a reminder, that's kind of what we're talking about here. Okay, so let's take our equation, and we're going to do the derivative of each side. So derivative of the left equals derivative of the right. A lot of the examples I've been doing have been set equal to a constant, so as you can see it's going to be 0 on the right side again. On the left side we can do the sum rule, and actually let's do the constant multiple rule here. So factor out that 2. That's going to be 0 on the right side. So now I just have to take the derivative of x squared with respect to x. That's just 2x. But the derivative of y squared with respect to x, okay, I want to point that out. That's first you do the derivative with respect to y, but y depends on x, so you multiply by the derivative of y with respect to x, like that. So there we go, equals 0. So now we want to solve for the dy over dx in there. So we'll subtract the 2x from both sides, negative 2x, and then we'll divide by 8y, 2 goes into 8 4 times, so our dy over dx actually equals negative x over 4y, like that. So now the idea is if, say, AB is a point on the ellipse, then the tangent line at that point is going to have the equation y minus the y coordinate, which is b, equals, and then we'll use this formula for the slope. X is a, y is b, so this would be negative a over 4b times x minus a. Now, you've got to make sure that you put the a and the b in there, because a and the b are the specific values for x and y. They're constants in this context. You don't want to put a function of x in for your slope. That is something that wouldn't make sense, because the only variables in this tangent line equation should be the x here and the y here. You should have no other x's and y's anywhere. So the a and the b are specific values of a specific point, which are put together in this specific way to give us the slope for that specific tangent line.